Welcome to Community Science Institute's Water Quality Database. This tutorial covers how to navigate the stream and lake monitoring portion of our database. Right now we're on the database's landing page, database.communityscience.org. Note that Community Science Institute is continually working to add to and improve our database. Because that's an ongoing process, what you see in this tutorial may differ slightly from what you see on your own computer screen. We're doing our best to keep these tutorials up to date as we make improvements to our database. If you look to the top left corner of your screen, you'll see the database menu. As you can see in this menu, there are two primary ways to interact with our stream and lake monitoring data. You can click this button to explore data online, or you can click this button to download the data to your own computer. In this tutorial, we will only be exploring data online. There will be a future tutorial covering how to search and download stream and lake data. So you click this button to explore stream and lake data online. That will bring you to this page, the landing page for the stream and lake data. The first thing that you'll see is a map with different colored pins on it. Each pin represents a different location or site where CSI volunteers collect data. And each color represents a distinct monitoring program, which you can learn more about on CSI's website or by scrolling to the bottom of this database page. You can zoom into the map by holding the Control or Command button and scrolling up. You can move around the map by clicking and dragging it, and you can even make the map full size by clicking this button. Navigating using the map is a great way to explore where we have different monitoring sites. If you click on any pin, a description of that location pops up under a site name, and if you were to click this site name, it would take you to a page for that location. But before we cover individual site pages, we'll explore the rest of this landing page. If you don't want to use the map, you can scroll down below the map where you'll see this table with different volunteer monitoring regions. The biggest category here is watershed, these blue hyperlinked regions here on the left. CSI has data from 10 different watersheds. Then we have subdivisions within each watershed. First, we have monitoring sets. Monitoring sets are groups of sites pooled together because they are on the same stream or in the same general area. Then we have monitoring locations. Each location is an individual site or one place on a stream or lake where volunteers visit to collect data. And finally, we have monitoring events. A monitoring event is a date on which monitoring occurred for a given monitoring set. And these distinctions will become more clear as we get deeper into the database. So the first option is to choose a watershed. Let's pick Cayuga Lake Watershed because that's where CSI has done the most monitoring. So we're going to click this blue hyperlink here. And once again, a map will pop up. But this time, it's only the pins that fall within this watershed. You can navigate this map just like you navigate the map on previous pages. So you can zoom in by holding Command or Control and scrolling up. You can click and drag, and you can still click on these individual sites and go to a site page if you choose. If you scroll down, you'll find the different monitoring sets within Cayuga Lake Watershed. So as you can see, most of these are grouped by individual creeks. And in this table, we first have the monitoring sets hyperlinked here on the left. Then again, we have these monitoring locations. In this column, it has the number of locations or individual sites that belong to each of these monitoring sets. So for example, looking at this, we can see that Trumansburg Creek has 12 locations. So when our Trumansburg Creek monitoring group collects data, they do that at 12 different sites along Trumansburg Creek. Again, then we have monitoring events. So each event is a day on which monitoring happened. With this same example of Trumansburg Creek, we can see that our Trumansburg Creek monitoring group has gone out to collect data 81 times. And then finally, the last column in this table is the latest event. So that means that the most recent data that's available for Trumansburg Creek, to continue our example, is from April 25th, 2023. You may notice that this is also hyperlinked. We'll get to that eventually, but first we'll look at a monitoring set. Let's look at Trumansburg Creek's monitoring set. So we'll click on this hyperlink, and then as usual, we'll come here and we'll see a map with all of these pins for each individual monitoring location. You can interact with this map in the same way as the maps on the other page. If we scroll down, instead of seeing another table right away, we see this automatically populated graph. On the x-axis of this graph, it has all of the locations monitored on Trumansburg Creek, starting from the mouth location, which is on the left side of the graph, to the location furthest upstream, which is on the far right side of the graph. On the y-axis, it shows us the average temperature. So this is an average of all the temperature measurements ever taken by CSI volunteers at each of these locations. So you might remember on the previous page, we saw that Trumansburg Creek had been sampled 81 times. So then these averages come from those 81 different values taken at different times. Finally, you may have noticed that each site has 2 points above it, not just one. This is because CSI separates out values we have from what we call base flow, which is when water is flowing normally, versus storm water, which is when the water is flowing faster because of a storm. So when our volunteers go out and there hasn't been a recent storm, and the water in the stream or lake looks relatively clear, not too deep, pretty typical, those are indications that this is a base flow event. If instead there is a recent storm and the water level looks elevated or it's flowing quickly, often it'll be brown and murky, those are indicators that that should be categorized as a stormwater event. And we separate these out because a lot of water quality indicators will differ quite a bit between the base flow and the stormwater. So the base flow averages on this graph are denoted by blue circles, whereas stormwater averages are denoted by these brown diamonds. So you can see that temperature is one of the water quality indicators that has a different average for base flow than stormwater. All of these stormwater averages, the brown diamonds, are lower in temperature than the base flow average values. And this graph is interactable in a few different ways. So because it's an average, you might wonder how many measurements it's an average of. And you can answer that question by hovering your mouse over each point, and that will give you the count. So here we can see the base flow average from this Camp Barton location. There are 41 events that are counted in this average. You can also toggle base flow and stormwater on and off. So maybe you're having a hard time seeing these stormwater locations with the base flow averages present. If you click on base flow, you can turn it off and you'll see only the stormwater, and this graph will adjust itself. So that's one way it's interactable. Another way that it's interactable is using this drop-down menu up here in the top right-hand corner. Here you can choose which water quality indicator you're interested in. So maybe I'm interested in chloride. Then I would select chloride from the drop-down menu and the graph will change. So we have the Trumansburg Creek sites here in the same order now, but we now see chloride on the y-axis instead of temperature. Now on this graph, there's also, in addition to the base flow average and the stormwater average values, there's a pink line labeled guidance value. Some water quality indicators have guidance values and others do not. That's partially because not all water quality indicators are regulated. So not all of them have guidelines for what a safe or healthy level in surface waters might look like. And because of these complexities, it can be difficult to determine which value, if any, CSI should include on our graphs on our database. So we do our best to choose appropriate values for appropriate water quality indicators, and those values are there just to give database users kind of a frame of reference for typical or healthy levels. It's important to point out that not every site has data on every water quality indicator represented in the drop-down menu. So for example, if I were to select magnesium, which is something that we almost never test for, then this graph will be empty. Now that's not an error, it's a demonstration that we don't have that data for this monitoring set. So now if you keep on scrolling down past the graph, you'll see that we have monitoring locations, or they can be called sampling locations. These are on the left side in this table. And then on the right side, we have monitoring events. So sampling locations, like we mentioned, are a specific site. Each one is a specific site where CSI volunteers collect data. And once again, these are all hyperlinked. So say we're interested in looking at the Lake Street Bridge site specifically, we would click here. So now, as usual, you're going to see this map of the location, but of course, because this is just a single site, there's only one point on this graph. Then if we scroll down, you'll see another automatically populated graph. This time on the x-axis, instead of locations, because this is all one location, you're going to see different monitoring events. So this x-axis is dates on which data were collected, ordered from the oldest, the least recent event when we collected data. So in this case, June 14th of 2006, up until the most recent event. And then on the y-axis, like before, you see the water quality indicator that you've chosen. So in this case, it's temperature. And so this graph gives a good sense of how levels of each water quality indicator have changed over time. So now looking at this graph, you can tell that we started monitoring this location in 2006, since that's the first monitoring date listed. Similarly to the previous graph, we have base flow and stormwater depicted by color. And as before, you can also select a different water quality indicator from the drop-down menu. So here, if we're curious about total hardness, we can select that, and we'll see that that measure is quite variable over the whole time that we've been monitoring here. Like before, we can hover over these bars for more information, such as the exact amount of total hardness that was detected on a particular monitoring event. Now, if we scroll down even further, we see the average value by month. So here we have the months on the x-axis for that same water quality indicator that we selected above. And that water quality indicator is depicted on the y-axis. So here we can see the average total hardness over the course of the year. Once again, we have base flow and stormwater. These are still toggleable like before. And then because these are averages again, if we hover over each of these bars, they will tell us the number of values that are being averaged. In this case, a lot of these bars only have one value, and so that's important to keep in mind when we're using this information. Now finally, at the very bottom of the monitoring location page where we are currently, you have some extra information about the site specifically. So we have a description, a rationale, so why we might be monitoring in this particular location. We have latitude and longitude, the type of location that it is, and the approximate distance in miles from the stream mouth. Okay, so now let's go back one page. You can do that by clicking here at the very top, or you can hit the back arrow. And now we'll dig into monitoring events. So here we're back on the Trumansburg Creek monitoring set page. We see this map at the top, just like we did before. Then we scroll down, we see the auto-populated average graph. And then at the very bottom, we have our monitoring locations on the left and our monitoring events on the right. Now, instead of clicking on a specific location, like we did before, we will click on an event. And remember, as we mentioned earlier, an event means a day when all the volunteers in a monitoring set went out to different locations along this stream to collect water samples. So if we click on October 26th, 2022, it's going to give us a snapshot synopsis of what Trumansburg Creek looked like on that day in terms of water quality. So the first thing that you'll see here is instead of a map, you will see a graph with all the different water quality indicators that were measured from that sampling event. So here on the x-axis, we have our monitoring locations from this monitoring set. Then on the y-axis, we have values. Then we have all these different colors which correspond to different water quality indicators. So one thing you might notice is that it's hard to see a lot of these bars, and that's because the graph is skewed by these purple bars, which represent specific conductance. And so one way to address this is to hover your mouse over each bar. It'll tell you the value of each bar, and the units, and the water quality indicator that it shows. But maybe a better way to do this is to toggle the water quality indicators off or on so that you can focus in on what you're curious about or just explore the data. So if we toggle off specific conductance, we'll get a much better read of the patterns among the other water quality indicators. Now, if you're curious about an overall snapshot of any given water quality indicator, the best way to do this might be to have only one water quality indicator toggled on at a time. So if we're toggling off everything except for total suspended solids, we can now pretty clearly see that this is by far the highest at Lake Street Bridge. And if we want, we can go through these water quality indicators one by one and look at how each of them measures up. Or maybe you're curious about related indicators like chloride and specific conductance. You can toggle both of those two on to see how they compare to each other. And you do kind of see these seem to be related, where the lower values tend to correspond with each other, and when one of them is higher, the other tends to also be higher. So that gives you the idea. This graph is really customizable to what you're interested in seeing. Scrolling down to the rest of the page, you'll see all of these same results, but instead of in a graph, they're in a table format, grouped by individual location. So this gives you some additional context for each of these results that you see here. For example, any additional remarks left by the lab, or whether the measurements were taken in the lab or in the field. So here you can see our temperature measurements are always taken in the field by our volunteers, while our other measurements are typically conducted in the lab. So that's how you explore our stream and lake data online. Thank you so much for watching this video. I hope that it's been helpful. If there's anything that you have any remaining questions on, feel free to contact Community Science Institute, and stay tuned for our next video, which will show you how to download the data for your own use.